the square root method. Maybe my favorite method because it's pretty easy. Add 16 to both sides. The goal here is to isolate your variable, not set it to 0, right? Just get the variable term by itself, and then solve by taking square roots. Okay, so let's take the square roots on this one. And you can see what happens here. You just got to be careful. I always got to do this on the right side, or the side with the non-variable term. Right? Why do I got to do that? Why do I got to do the plus or minus thing? Square root of 16 is 4. Because I got to realize that there's two solutions to this equation. If I plug in my original equation is x squared minus 16 equals 0. If I plug in a 4 here, 16 minus 16 is 0. But if I plug a negative 4 here, negative 4 squared is positive 16. So both of those are going to work. So I always got to do the plus or minus when I do this key step of taking a root. Oh, we solved this one already. Remember, you can look at the previous video. We got two solutions for this. I believe it was plus or minus 5/2, and we solved it by factoring. So let's see if we get the same thing. We should. That is, I'm going to add 25 to both sides. So I get 4x squared equals 25. Remember the goal of solving by taking roots. Isolate your variable term. So I've done that. X squared equals 25/4. And then I take the square root of both sides. I do my plus or minus. It gives me x equals plus or minus square root of 25 is 5. Square root of 4 is 2. So I do get the same thing I got when I factor. Taking square roots, pretty straightforward. Let's move on to completing the square. Alright, so I got to solve this thing by completing the square. So in this case, I'm not going to set my equation to 0. I'm going to create what's called a perfect square trinomial, right? And that means I got to get rid of this guy because that's what's messing me up. So I'm going to add 11 to both sides. Alright, so that's my first step here. Plus 11 plus 11. I get 11 over here. And now we need to complete the square. I need a constant here. The 11's messed me up. I need to add a number to my two x terms to create a perfect square trinomial. And here's the rule, and I'll explain it later. You take half of the coefficient of x, half of that number, and you square it. Half of 6 is 3. 3 squared is 9. And I got to add that to both sides. I'll explain why that works in a second. So just believe me for now that 9 in this case is the magic number that completes the square. So I got to add it to the left side of the equation. But if I add it to the left, I got to add it to the right to keep my equality. All right. And now why is 9 so special? Why does taking half of 6 and squaring it work? Well, I'll show you. Factor this thing. That's a perfect square trinomial. Remember, we factored these before. We said I need two numbers that multiply together to give me 9 and add together to give me 6. In this case, those two numbers are 3 and 3. Same number. And that'll always work. That's a perfect square, right? That's x plus 3 squared. And that's how I'm going to write this from now on. And it's equal to 20. All right, we've created a perfect square trinomial. Now I can solve by taking square roots. I'm going to take the square of that, do plus or minus. The square root of x plus 3 squared is just x plus 3. And then equals plus or minus root 20. So you're going to get funny looking answers for this. I'm going to subtract 3 from both sides and I'll have my answer. Right, I just want to fix my root 20. So a little side note, a little side review. We can simplify these guys by breaking them up in the product. What's the largest perfect square that goes into 20? It's 4. 4 times 5 is 20. So root 20 should be written as 2 root 5. Okay, did you follow all of that? Look at that answer. 2 answers there, plus and a minus. Okay, so just a quick review on that one. What number completes the square? Or what do I do first? Let's start there. Get rid of that number. Whatever that number is, we don't like it. Move them over by adding in this case. And then what number completes the square? Take half of this and square it. That'll work every time because what we're doing is creating a perfect square trinomial. Let's do another one. Get rid of the 48. Don't like that. He's messing us up. Subtract it from both sides. That leaves me with x squared minus 16x. I do like a blank equals negative 48. And then I complete the square. Take half of 16 and square it. So half of 16 is 8. 8 squared is 64. So I'm going to add 64 to both sides. Okay, I got to combine these. That should be 16 is what I should get over here. 16 when I add those together. And now this should factor like this. Right? Because we forced it to factor like that. We created a perfect square trinomial by completing the square. So the question would be, two numbers that multiply together give me 64, add together give me negative 16. That's negative 8 and negative 8. And now I go from here. Square root, plus or minus. In this case, I can take the square root of 16. It's 4. So I get x minus 8 equals plus or minus 4, square root of 16. And then I add 8 to both sides. And I get x equals 8 plus or minus 4. So that's 8 plus 4 is 12. 8 minus 4 is 4. Okay, that one it looks like would have factored. If I get nice integer solutions or rational solutions, that means there's a good chance that would have factored. Or it means it would have factored. But I didn't do it by factoring. I did it by completing the square. Sometimes you can do two different methods. All right, one more. This guy, I can add 9 to both sides. You might recognize, well, let's see. This one I think will factor. Let's say we do this by factoring. It's going to be a lot easier. That was easy. Two numbers that multiply together give you, oh wait, that's not correct. I take that back. That's a common error. This is how I thought of factor, but if this would be x squared. If I FOIL this out, what do I get? X squared minus 3x minus 3x minus 6x plus 9. I was looking at it wrong. That's not right. So it does not factor, at least I don't think it factors. Let's just follow the directions and complete the square. See what happens. All right, let's get rid of the 9. Blank. Add 9 to both sides, right? That's why it's positive over here. Complete the square. Take half of 3 and square it. That's 9. And then I get 18 on the left or the right hand side. And this has to factor as a perfect square because we've created it. Two numbers that multiply together give you 9. Add together to give you 6. 3 and 3. And now I'm in good shape. I'm a couple steps away from my solution. Square root plus or minus. And then that means x plus 3 equals plus or minus root 18. Do we want to deal with the root 18 now? Let's do it. Is there a perfect square that goes into 18? There is. It's root 9. Check my math. 9 times 2 is 18. So the square root of 9 is 3 root 2. All right. And then I'm one step away from the answer. Got to subtract 3 and just rewrite 18 how I like it. So I got x equals negative 3 plus or minus 3 root 2. Next up, one more method, quadratic formula.